Hello and welcome back to Curious Planet. This video is part of my Geology Foundation series. The goal of this series is to lay conceptual groundwork for my future videos and for your own adventures. Today we're talking about metamorphic rocks. In my first video, I compared metamorphic rocks to orcs.
What about their legs? They don't need those.
And that's because orcs used to be elves before they were corrupted by fire and shadow. Well, metamorphic rocks used to be regular rocks before they were altered by heat and pressure. And it's varying amounts of heat and pressure that give us different types of metamorphic rocks. And just like Lord of the Rings, metamorphic rocks are just plain cool. I mean, look at these things. You just don't get textures like this in regular rocks. So what's going on? Well, if you watch my igneous rocks video, you'll know that rocks begin as molten magma deep beneath the earth. And then depending on where and how that magma cools, determines on what kind of rock will form. Well, since metamorphic rocks are resubjected to extreme temperatures, they partially melt. And this partial melting allows for new crystals to form inside of an already formed rock. Now you can imagine if this happens over and over again, or the rock is subjected to extremely high temperatures and rare deep earth minerals start to form inside of it, you can start making some pretty crazy looking rocks. And metamorphic rocks are also subjected to extreme pressures. I mean, just look at this rock. You can imagine how the layers used to be straight, but then once they were subjected to extreme pressure, they just folded up like an accordion. But metamorphic alteration isn't always so extreme. Metamorphic rocks that form under small amounts of heat and pressure are called low grade and may only show slight alteration. Whereas metamorphic rocks that are subjected to extreme heats and pressure are high grade and may be significantly altered. Take a look at this chart.
Look at this graph.
Here, pressure increases as you go up the y-axis, and temperature increases as you go up the x-axis. All the funny names in the chart just represent the known conditions where certain metamorphic rocks like to form. We call these metamorphic facies. And we can see that metamorphic rocks are able to form across many different combinations of heat and pressure, corresponding to drastically different conditions. So the presence of certain metamorphic rocks can give us a lot of information about how an area we're studying may have formed. And this is made simpler by the fact that most of the metamorphic facies are just named after rocks. So if you can identify the rock, you can just do a simple match onto the chart, and then you can extrapolate the formation conditions of the area that you're studying. For example, this rock is granulite. We can see on the chart that granulite tends to form under extreme temperature and pressure. So we could assume that this rock at one point was forced to be buried deep underground where the temperature and the pressure is really high, probably in some kind of mountain building event. This is blue schist. If we look at the chart, we see blue schist forms under great pressure but low temperature. So this might cue us into a place where rocks are grinding past one another deep under cold water, like a subduction zone. This rock is hornfels. If we look at the chart, we can see hornfels forms under conditions of high temperature but low pressure. So we could assume that this thing at one point was somewhere really hot but not very deep, like maybe on the margin of a rising body of magma. That's a lot of information that you can infer from just a single rock. And if you look at all the rocks across a whole area, then you can start piecing together a coherent story of what our planet was doing millions of years ago. I think that's pretty cool. All right, that's enough for this one. As always, leave your questions and suggestions below. And until next time, stay curious.